Um, I was asked some questions about, bless you, um, fundamental theorem of calculus, which the word fundamental, it's going to be on there some way or another. So I thought that was a good thing to review. And I was also asked about polars. So I have, uh, this is 2018, and I think the other is 2017. So if you didn't try these, actually, and if you did, can you give these a go? Good morning. Good morning. I'm surprised to see so many seniors. Sounded like a computer. Camden, you're being pensive without pencil. Can someone tell me how we would do f of -6? Like, I have a way of showing it, but yeah, Gabe, what would you do?
Um, it gives you f of -2 equals 7. So 7 plus the integral of f prime vector between -2 and -6.
Okay. And you said 7, and I wrote the f of -2 in the land of, like, am I be helpful to write it this way, to be like, I know what I'm doing. Anchored down here, this is how much stuff is changing, and that is gonna give me f of -6. I don't think they would, I think it's fine with the 7 as well, but this is it's being more obvious. Okay, so what is this integral? How would we evaluate that? Josh, how would we do that?
Area of the triangle.
Area of the triangles, it's negative, what? It looks like 1, 2, 3, 4 by 1, 2.
Means 40.
Okay. So that works. My concern with showing it this way is that you guys won't know that it's negative, but you did. I like to move forward, so the way I write this, starting at -6, moving forward. That gives me f of -2, and then I do the algebra and move things over. And I end up subtracting this. They're the same thing. I end up subtracting that area above the curve, whereas you guys had to find the negative area. It's written out. Either way, they're both right, just it resonates differently. F of 5. Hadley, what do we do to find f of 5?
The same thing, so f of -2 plus the integral from -2 to 5.
So where did you start and add the amount of change? So, Roxana, how do I get the integral from -2 to 5?
I did geometrically again.
Yep.
So we already have the triangle, and then the semicircle is pi r squared divided by 2, which was 2 pi. So subtract 2 pi. And then 3 plus 3 for the triangle.
3 by 2, so that's a 3 for the triangle.
So we got 14 minus 2 pi.
Am I including this triangle or no?
Oh, no. So never mind.
Okay, so where did it start? At f of, so this is why, starting here, you said correctly, that area, half of that circle, and it's negative because it's below the x-axis, and then we need to add on the 3. So, like, show for yourself, what are you doing? Where are you starting? Where are you going? Are you going forward? Or are you going backward? Is the area above? Is it below? Especially those of you that live in the 64s. Like you're so close. Okay. What intervals is f increasing? Sasha, what do we look for to find where something is increasing?
Where the graph of f prime of x is positive.
Okay. So where f prime of x is greater than 0, f is increasing, so that's where?
It's -6 to -2 to 2 to 5.
So anywhere that f prime is positive. Okay. Absolute minimum. Uh, Absolute minimum.
So first I thought we were at prime of x is 0, so at negative 2 and 2.
Okay, f prime, where is f prime 0? Negative 2 and 2, okay.
And then I made like a table, so negative 6 or xy, and then negative 6, negative 2. 2 and 5. And then I put in all the values of f of x for this, so
Because we did just find f of negative 6, which was
4 or 3, sorry.
negative 6 was, and at 5 we got,
And that 5 was 10 minus 2 pi.
which one of those is bigger? 10 minus 2 pi or 3? Which one's bigger? 10 minus 2 pi? Okay, because 2 pi is 6 and change, but it's not 7, so, okay. Then what about the negative 2 and the 2?
And negative 2 can do at 7, and then 2 is negative 2 pi.
And it
Or,
asks,
sorry, 7 minus 2 pi. Yeah. 32.
Doing the same exam, do we need to include negative 2 in our table, even though it's like a level maximum?
you know, sometimes. Sometimes there's a point in the rubric that says, we're looking for maximums. We're gonna ask you, like, that you checked the interior, which has only got a minimum, but you needed to have checked the interior. So to be safe, this is lovely. So what's the lowest number of all the numbers? Because it says find the absolute minimum value. It didn't say where, it says what is it. So what's the lowest value? 7 minus 2 pi. And look, the table looks familiar. Considers x equals 2, didn't care about the negative 2 this time. So, but I have seen it where they have in the rubric, there was only one critical point and it was not the one they wanted. They asked for maximums and it was a minimum. They wanted you to consider it. Double derivative at 5. How do we find double derivative given the first derivative? Slope. So what's the double derivative at negative 5? Reading it right. Negative 1 over 2 or negative 2 over 4. And yeah, you just count the boxes. Sean, what's the double derivative at 3?
Doesn't exist.
Because,
It's a, or,
so what's the slope at a corner? None. It isn't. So fundamental theorem of calculus, feel okay with things? Yeah.
On the answer sheet, they did do a lot of limits and stuff. Do we do that or do we just say?
Wait, let's see. So at negative 5, they just found the slope, and the does not exist with explanation. I would say if you said because it's a corner, that's fine, because corner kind of means that the slope from one side and the other is not the same. And again, I'll be able to tell you more detail on June 12th, what they actually want. That's when grading starts, yay! So that people can read this, have an idea of the picture. Is Can you see that in the back, or should I make it bigger, Camden? Sorry. Do you need to evaluate the first part? So don't waste time on evaluating, just set it up. So Sean, what is the setup for part A? Don't know.
Interval from pi over 3 to pi over 3. And then 16 minus 3 plus 2 cosine theta squared. And then 1/2 on the outside.
$16, 4 squared, whatever, either one. But so what he just did was radius squared minus radius squared. And area of a circle is pi r squared. Area of the pi piece is how much of that full circle are you looking to use? The pi's end up canceling out, and it's half r squared. And the theta is, well, since the radius is changing, I need to integrate as that angle's changing over time. So that's where the formula comes from, yeah.
Isn't it minus the zero?
Sorry, yes. Did you say minus? And I
Yeah.
wrote plus.
Yep.
Okay. Yep, minus. I'm not taking the test, you guys. Okay. Part B is tedious. Did anyone finish yet? Camden, what'd you get? 2/3. Okay, what was your process?
I found y and x was r times sine theta, y times cosine theta, and then the derivatives of each, and then I just plugged in pi over 2, and that was it.
Said R, Y is R sine theta, and X is R cosine theta. So I don't see this particular question on there often, but this is 2017, 2018, it can happen. And sometimes your process, like how you set up your work, will really help solve things. I always do product the same way. First times the derivative of the second plus second times the derivative of the first over first times the derivative of the second plus second times the derivative of the first. Like a lot of this lines up and will be the same thing, and it's a way to double check, did I get the same thing twice? Did I forget the negative twice? Like, what is going on? And then don't simplify anything from there. We want to evaluate dy dx at theta equals pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. And then be careful with this one. Cosine of pi over 2 is 0, but it's 3 plus 0. On one of the quizzes that we had, you guys plugged in stuff and you're like, oh, that's 0, so the whole thing goes away. No, 3 plus 0 is 3 times that negative 1. Okay, but here, all right, that one's valid, that's a 0, and we get Camden's answer of 2/3. And that's about all the work you need to show. You didn't need to clean any of this purple stuff up. And Camden's like, no, I don't do that. You told me I didn't have to. Yeah, but part C. Not parse the words. What are they looking for? What did they give you? What is that? Hannah, what is it?
dRdt.
How is the radius changing? That's the distance from the origin to the particle over time. It's increasing at a constant rate of 3. What are we looking for?
d theta dt.
Okay. How are we gonna find that? Like, what equation do you have to start with? R. Okay. Kai, what do I do with R?
Take the derivative dt.
Do the derivative with respect to time, okay?
This Pascal, isn't it? 3 plus 2.
Copy, not a strong suit. Okay, you said do the derivative with respect to t. All right, I'll do the hard one. Now your turn. What's the derivative?
-2 sine theta times theta dt.
So implicit differentiation. What's the derivative of the radius with respect to time? What's the derivative of the angle with respect to time? And then plug things in. The RDT is 3. Okay, unit circle. 5, 5, 3. 3 over 2. Okay. Okay. So Kai chose to do the derivative that way right off. I imagine a lot of you would have done this. Please, like, if you guys are still using R prime, don't. Yeah,
Isn't that like 3 over -3?
yes, and that would be right also. But dRd theta, if I did the derivative like normal, that's not going away, though. Derivative 3 goes away, derivative of 2 cosine is -2 sine. I didn't want dRd theta, I wanted dRdt. You can do the unit conversion thing later. I don't know your choice. All right, these are the things that were requested earlier this morning from others.
Could you do an example problem of the blue or like blue?
Voodoo? Um, trig or E, which one? And I'm not gonna put bounds on it. Because I don't want to. So there's 2 methods. One is really not recommended. What would you guys do with this one? Tabular. The acronym to choosing the U and the V. So this is the Voodoo VDU. Choosing U. Choosing the U, usually we want the derivative to eventually go to 0. That's when tabular works. And if it doesn't go to 0, if you have log, choose that first, then inverse trig, then polynomials, then E, then trig. The DV is something that's easy to integrate. Also known as the leftovers. So you do the derivative until it goes to 0. The other side, we're going to integrate carefully. Whose derivative is positive sine?
It's negative.
Negative cosine. whose derivative is negative cosine is negative sine, whose derivative is negative sine, positive cosine. Then what do we need to do? Preston's doing the arrows, but what? So those guys multiply, but there's something else.
Like the first one's positive, and the second one's negative, and then the third one's.
Okay, and
Well,
yes.
Yeah, but the signs will.
okay, so the first one, the signs stay the same, whatever they were. The next one, the signs swap, and then the signs stay the same, back and forth. Okay. So this is gonna integrate to be that's my first term, those two multiplied together. Use the parentheses, if you don't have the parentheses, it's wrong. Then plus the next terms, 6x plus 2 times, and then negative and a negative became positive. And then the last one, and then plus c. And if you weren't doing it by tabular, I mean, you can do all of them by tabular. Minus the chase your own tail one. It's just-
And so you can do all the tabular except the
Yeah, the chase your own tail kind.
Would they ever put that one?
Would they ever? If they do, that one would be on free response and it would be a pain. It's 3 steps, right? Doesn't matter which one of those you choose as the U value, but whatever you choose it, whichever way you choose it, be consistent. So this becomes, and I will write it, UV minus the integral of v du. Did I do that right? Feels wrong. V du. Yeah, I'm like, I don't get it yet. VDU. So there was a negative that I had to change. Okay, so this is what I meant by whatever you chose as your U value up here, be consistent and choose again. If you chose trig first here, choose trig first again. So all of this is negative e to the x cosine x plus uv minus the integral of v du. You guys remember what we did from here? Add, and Kelly says add to the other side, so add this. So we have 2 of these equals negative e to the x cosine x plus e to the x sine x.
I just wanted to say good luck on Monday. This is BC, right?
Yes.
This is not okay. Good luck. You're gonna crush it.
What did I forget?
See,
If you do have bounds, you just do the whole thing to the number, like minus the other whole thing to the number.
Yeah, okay, so if this was. I don't know, 0 to pi. Plug in pi and that would be rude, like make it be a chase your own tail and evaluate it.
Yeah.
And it's AP, they can do anything. Yep.
well, when you do, actually, never mind. I was thinking like do substitution or strategic things. So,
Right, if it would be that would be a new kind of horror. New substitution with changing bounds on an integration by parts that's a chase your own
yeah,
tail.
yeah.
Yes! That would be so cool. Chapter 6 test next year. Yeah. You have survived, don't tell, don't tell. Oh, okay, I think I just lied.
To make the whole test one problem.
Who's done that? There's
They
like,
forget the plus C, they don't get any credit.
see, that was the case in my high school days. David had a single plus C on the whole thing, he got a 0 out of 30. And he had a big black Sharpie marker the next day on the board, on the wall, he wrote plus C, like the size of, yeah. It might still be there. He's like, he's fine, he's at MIT as a professor, he's fine. This one is integration by parts. So, would you recognize that? No. And why you don't recognize it is the DV is empty. So UV minus the integral of V to U, 1 over x times x is just 1. So that one you don't, like, in limit, if it's log or inverse trig, tabular probably doesn't work so well. But if it's polynomial stuff, that's tabular. Aha, wrinkles. Any other issues? Do you guys remember how to do double derivative of a parametric? Only way back. Say thank Gabe for this. It's all his fault. There's the first derivative. Preston, did I do something wrong? It is. Again, I'm not taking the test, you guys are. But I asked for double derivative. Which is Alex, how do I do that?
Don't you?
I need to do the derivative of that. Okay. How do I do that? You said quotient rule.
Yeah, divided by dx and dt again.
Okay, well, first, quotient rule that.
T squared. Negative 5t squared times sine t. Or that works too. It's minus cosine t times 10t. Divided by 5t squared squared. All of it squared. Then you have to divide it by dx and dt.
And that's so that this green stuff is the double change in y divided by dx divided by dt. It's that. And when we divide by this, wrong way. Wrong way. So sorry. Double change of y over the double change of x. So this doesn't clean up a lot, but some 5s cancel out. But that's your double derivative, is to remember, divide by the dx dt again. Yay. Alright, there's one last thing left on Delta Math that some people have not finished, and it's the calculator problems, and that's to remind you how to use your calculator. And then Sunday night, as you're finishing, because it's due Sunday night, you will also realize that you do or do not have batteries for your calculator, or that you do or do not have it charged. So do that. And a reminder, I do bribe you to come to school early. I will have food here at 7 on Monday morning. And that's to make sure that you come to the exam. You guys get food motivated, just like my dog. I keep reaching in my pocket. I call them fast forward buttons. She won't walk if you don't throw a kibble out every 10 feet. I'm like, no. I jipped her by 3 kibbles this morning. But yeah, so yay, food.
What time should we get there?
The test, I believe, is when have they been starting? It's supposed to be starting at 7:45, but probably actually after administration and talking to you and making you sit down and then maybe instructions. The earliest you'll start is at 8, and it's long. It's a long test, and I will be here in the morning, but I won't be here in the afternoon. Yay! Go you!
Wait, how long is the test?
Long, like 3.5 hours. Because if you think about it, 15 minutes for each for your response, so that's an hour and a half. An hour for the multiple choice without calculators, that's 2.5, and then 45 minutes for the with calculator. 3 hours and 15, and they give you a little bit of break in there. It's a long test.
Do they give us like 2 FRQs at a time?
They give you the first 2 FRQs that you can use a calculator, and they give you 30 minutes. and that at end of the 30 minutes, you have to put the calculator away, but then you can open the other 4 free response questions and you can work on any of them the rest of the time. So you can go back to question 1, just not with the calculator anymore. So there are a number of students on the wall whose calculator ran out of batteries and they said, it's okay, I don't care, you didn't let us use the calculator all year anyway. Because a lot of the questions you can get without the calculator anyway. Like you can get the points for the setup, you might not be able to actually get the number, but you can get the setup. Any other questions on how it plays out? Yeah.
This is not really math related, but you're also allowed to bring drinks.
You're allowed to have stuff under, like those of you who've taken the test already, you're allowed to have water and a snack like under your desk.
It has to be in a clear plastic bag.
Or just unwrapped. Like, so some of the food that I will provide you with, like cheese sticks, that come in its own plastic wrappers, and you can just take it and it doesn't have any bags. Clementine, granola bars, things that are sealed. Yeah.
Do you use pencils or pens?
Pencils.